Hello and welcome back. Let's continue our class of foundation engineering. We are going to see 2 points on the chapter 5, the settlement of shallow foundation. Okay. The first one will be secondary consolidation, and the second one will be field load test. Okay, with plate load test. Yeah. So after the first consolidation, we have another consolidation coming, and that is the secondary consolidation. So there is settlement due to the secondary consolidation as well. And we are going to see how to estimate that settlement, the amount of settlement due to the secondary consolidation. Okay. So let's define it first. The definition of secondary consolidation, I think I already defined it. At the end of primary consolidation. Remember that primary consolidation was mainly for removing the water from the clay, like the time for the water in the clay to escape. Okay, so that is primary consolidation. Then after that primary consolidation, we have another consolidation due to the plastic soil fabric adjustment. This is just the soil particles will adjust in the soil. Okay, so it will reduce because after all the water is gone, the soil skeleton is fully receiving, supporting the load. Okay, when the water is in the soil, water is helping to support the load. But once the all the water is gone, means end of primary consolidation. Okay, then the total load is on the soil skeleton, and that will make the soil particle to adjust, and that the beginning of the secondary consolidation. Okay, we have a curve here, and it can help us explain this, help us understand. You have here like the first, okay, primary consolidation doing like this, and from here maybe it's the primary consolidation is finished. It means all the water in the clay is gone. Now settlement is still going on due to the rearrangement of the soil particle, adjustment of soil particle, soil fabrics. Okay, so there is a very special parameter that we need from this second part of the curve. Okay, this one. As you can see here, we have small delta here. So from this curve, B can get what we call the secondary compression index. Okay, the secondary compression index. That is the special parameter we need, and this is this one already. It is here. Okay, it is defined here in the figure, but the formula is given here. So delta E, as you can see, this is void ratio and this is time. Okay, void ratio is directly linked to the volume, right? So the delta E here and the time here. These two are what you use to obtain this C alpha. Okay, the secondary compression index. This secondary compression index will help us to estimate the settlement due to the secondary consolidation. Okay, so we have the name already, you know, this coefficient as already here. Secondary compression index. Okay, this index, because we know other index before. So delta E, I think you know already, it changing the void ratio for this only this area at the end of the primary consolidation. Okay, and T1, T2, this is just time. It doesn't matter where you take T2. And the magnitude of the secondary consolidation can be calculated using this equation. Okay, remember T2 is just the time you take. It doesn't have limit. Okay, you can go here if you want. Okay, but each T2 will come up with delta E, corresponding delta E. Okay, so here is equation we need. Okay, this equation will help us to obtain the amount of settlement caused by the secondary consolidation. Okay, this one, as you can guess, it related to this one. Okay, C prime alpha, and it is obtained from this, the coefficient secondary compression index, by just adding using EP. Okay, EP is here, is defined here. You do this line, okay, the tangents, and this tangent, where this tangent meet, will give you the EP. And this is what you use here to calculate this prime, the C alpha prime. Okay, and you will use it to estimate the settlement due to the secondary consolidation. HC, I think you know already, it's the thickness of the clay layer. Okay, EP is the void ratio at the end of primary consolidation. This is EP, void ratio at the end of primary consolidation, defined already. Okay, HC, thickness of clay layer. So now you have everything. Okay, so you have to take this settlement, this amount of settlement plus the settlement due to the primary consolidation, and then you have the total amount of settlement, okay, in time. Now let me keep these two equations here. So as you can see, the equation for this one, equation of C prime alpha, is not easy to deal with. Okay, we need we need EP, void ratio at the end of primary consolidation. We need thickness. We need this one. Yeah, we need the EP, the void ratio at the end of primary consolidation, and that is sometimes not easy. So there are some references. Okay, for example, this one, try to propose some value, some ways, easy ways to obtain the value of C prime alpha. Okay, this one is proposing to obtain it just from the water content, W. Okay, so saying you take this equal about 0.0001 times the water content, natural water content. Okay, so that make it easy, right? So if you have the water content that can be estimated in the lab easily, natural water content, and you can just replace it here. Okay, then you can calculate the settlement of due to the secondary consolidation easily. Okay, natural water content, natural moisture content. Okay, and for over consolidated clay, you will have this value between this and this 0.005 to 0.001, between these two. It's small actually. Okay, and this is one reference. We have another reference, this one, proposing a way to obtain again this value, saying that the ratio between this and this one can be about this, with this is the error of 0 point, a small error. So be careful here. This one giving you the value of this index, okay? Because you can get this index easily. We show the lab test giving this, but this one is not easy to obtain sometimes. So you can get this, use this also. And for organic clay and silt, you have this. For peat, you have this approximation. And to finish this about the secondary consolidation, remember that this secondary consolidation, settlement due to the secondary consolidation, is sometimes more important than the primary consolidation in some soils. And that includes uh, all organic soils, okay? And some highly compressible inorganic soils. So if you take organic soil, the primary consolidation will not be that much compared to the secondary consolidation. This is because in this kind of soil, organic soil, it's like it really compressible, highly compressible. The soil itself is compressible because it's like sometimes mix of with vegetable, doesn't have strength. Okay, I think that will be all for consolidation. Yeah, so we have this easy way to obtain the secondary consolidation. You have this from water, natural water content, you use it here. Okay, you have the thickness of the clay layer and time now it depends from what time to what time you want to. Okay, yeah, if you suppose that T1 is at the end of the primary consolidation, so then T2 you can choose it in 2 years, in 5 years, in uh, when I say in 2 years, 5 years, it means 2 years after the end of primary consolidation, which you know how to calculate it, how to calculate already. Okay, let's move to the next section. The next section is field load test. This is about plate load test. So plate load test is field method to estimate ultimate capacity and allowable capacity of foundation, shallow foundation. Okay. So we have same equivalent in case of pile, also deep foundation. But for shallow foundation, we have plate load test. Okay. How does it work? You use a plate, steel plate, with this kind of dimension, typical dimension, okay, thickness 25, and the diameter can vary between 150 and 762, okay. Sometimes they use square plate instead of a circular, and 305, kind of. So this is illustration. So this is the plate, okay, and you dig this hole and you perform loading. Okay, how does it work exactly? To conduct the test, okay, you excavate to make a pit at the same level, okay, where your foundation will come. Okay, this the depth of this, where your foundation, it should be the same depth of your future foundation footing. Okay, and the dimension of this pit should be at least 4 times b, b being the plate diameter. Okay, we have